We humans have always been fascinated by intelligence. It's what sets us apart. It allows us to learn, adapt, and create. But what if we could create intelligence artificially? That's the promise of artificial intelligence, or AI. AI is about building machines that can perform tasks that normally require human intelligence. Think of a computer playing chess or a car driving itself. These are all examples of AI in action. AI is rapidly changing our world. From healthcare to finance, transportation to entertainment, AI is making its mark. It's automating tasks, providing insights, and even augmenting human capabilities. The future of AI is full of possibilities. As we continue to develop more sophisticated AI systems, we can expect even greater advancements in the years to come. Deep learning is a powerful type of AI. It allows machines to learn from vast amounts of data. Think of it as the brain behind some of the most impressive AI applications we see today. Traditional machine learning relies on humans to manually define features and rules. Deep learning, on the other hand, learns these features directly from the data. This allows deep learning models to handle complex tasks that were previously impossible for machines. Imagine a deep learning model trained to recognize cats in pictures. Instead of being told what a cat looks like, the model learns those features by analyzing millions of images. This ability to learn from raw data is what makes deep learning so powerful. Deep learning is revolutionizing the field of AI. It's the driving force behind breakthroughs in areas like image recognition, natural language processing, and even drug discovery. At the heart of deep learning are artificial neural networks. These networks are inspired by the structure of the human brain. Just like our brains have interconnected neurons, neural networks have interconnected nodes. Each node in a neural network performs a simple calculation. These calculations are then passed on to other nodes in the network. This process continues through multiple layers, with each layer learning increasingly complex representations of the data. Think of it like this: the first layer of a network might learn simple features, like edges in an image. The next layer might combine these edges to recognize shapes. Finally, the last layer might use these shapes to identify objects. The more layers a neural network has, the deeper it is. And the deeper the network, the more complex the patterns it can learn. This depth is what gives deep learning its name. The journey of deep learning is marked by significant milestones. Each breakthrough has pushed the boundaries of what's possible with AI. In the 1940s, the first artificial neuron was created, laying the foundation for neural networks. The 1980s saw the development of backpropagation, a key algorithm for training deep neural networks. However, it wasn't until the 2010s that deep learning truly took off. This was fueled by the availability of massive datasets and the development of powerful GPUs, or graphics processing units, capable of handling the immense computational demands of deep learning. The ImageNet Challenge, a competition for image recognition, became a turning point. In 2012, a deep learning model called AlexNet significantly outperformed all previous approaches. This victory marked a watershed moment, showcasing the power of deep learning to the world. Section 5. Deep Learning in Action, From Vision to Language. Deep learning is no longer a futuristic concept confined to research labs. It's all around us, powering applications we use every day. Think about the last time you used a virtual assistant like Siri or Alexa. These assistants rely on deep learning for speech recognition and natural language understanding. Or consider the facial recognition technology used to unlock your smartphone. That's deep learning at work again, analyzing your facial features and matching them to stored data. From self-driving cars to personalized medicine, deep learning is transforming industries across the board. It's helping us solve complex problems, automate tasks, and make more informed decisions. Section 6. The Power of Images. Deep Learning in Computer Vision. Computer vision, the ability of computers to see and interpret images, has been revolutionized by deep learning. Tasks that were once considered challenging for machines are now performed with remarkable accuracy. Deep learning models excel at object detection, identifying and localizing objects within images. This technology is used in self-driving cars to detect pedestrians, traffic lights, and other vehicles. Image classification, another area where deep learning shines, involves assigning a label to an entire image. This is used in medical imaging to diagnose diseases based on X-rays or MRI scans. Deep learning is also used to generate realistic images. Generative adversarial networks, or GANs, can create stunningly realistic images that are almost indistinguishable from real photographs. Section 7. Deciphering Human Language Deep Learning in NLP. Natural Language Processing, or NLP, focuses on enabling computers to understand and process human language. Deep learning has brought about significant advancements in this field. Machine translation, the automatic translation of text from one language to another, has seen dramatic improvements thanks to deep learning. Platforms like Google Translate now offer highly accurate translations for a wide range of languages. Sentiment analysis, which involves determining the emotional tone or sentiment expressed in text, is another area where deep learning excels. This technology is used by companies to analyze customer reviews and understand public opinion. Chatbots, powered by deep learning, are becoming increasingly sophisticated. They can hold conversations, answer questions, and even provide customer support, mimicking human-like interactions. Section 8. Challenges on the Horizon. Deep learning's uncharted territory. Despite its remarkable achievements, deep learning still faces challenges. Addressing these challenges is crucial for unlocking the full potential of AI. One major challenge is the need for massive datasets. Deep learning models typically require huge amounts of data to train effectively. Obtaining and labeling such datasets can be time-consuming and expensive. Another challenge is the black box problem. Deep learning models can be difficult to interpret. Understanding why a model makes a particular prediction can be challenging, making it difficult to trust their decisions in critical applications. Ethical concerns also surround the use of deep learning. Bias in training data can lead to biased outcomes. Ensuring fairness, transparency, and accountability in deep learning systems is paramount. Section 9. Deep Learning's Promise. A future shaped by AI. Deep learning is a powerful tool that has the potential to revolutionize countless industries and aspects of our lives. As research progresses and technology advances, we can expect even more groundbreaking applications in the future. In healthcare, deep learning could lead to earlier and more accurate diagnoses, personalized treatments, and even the discovery of new drugs. In manufacturing, deep learning could optimize production processes, improve quality control, and enable the creation of smarter, more autonomous robots. The possibilities are limitless. Deep learning is not merely about building smarter machines, it's about augmenting human capabilities, solving complex problems, and creating a better future for all.